Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and let's talk about shaders. Again, so when you write a shader in GameMaker, most of the time what you'll use, and what I've used so far in these shader videos so far, is a shader language known as GLSL ES. That is the short name for the Open Graphics Library shader language for embedded systems, which nobody calls it because that is quite a mouthful. This is what it looks like. It's vaguely similar to C in its syntax if you've ever used the C programming language before, if I had to compare it to something. GLSL ES is not the only shader language you can use. In fact, if depending on your target platform, it may very well not be the language that your game is actually using as its shader language. When you run your game on Windows-based platforms, so that's just the regular Windows runner, which 95% of you are using right now, or if you're trying to make a game for the universal Windows platform, such as the Windows 10 Store or the Windows Phone, which I'm fairly confident that nobody's actually doing, or even if you're trying to make your game run on something like an Xbox, your game will actually be using something called the high-level shader language, HLSL, as its shader language. Even if you write your shader code like this, which I obviously am, and if you're running your game on a Windows-based platform, which I, again, obviously am, GameMaker will actually convert this into a different shader language behind the scenes every time you run your game. If, on the other hand, you are trying to make your game for something like a Macintosh computer or some other Apple product, then your game will instead be running it instead of GLSL for embedded systems, with the ES on the end. Your game will be using GLSL as its shader language, and again, you can write your shaders in regular old GLSL ES like this, and GameMaker will convert it to the appropriate language when it needs to. If you're making a game for PlayStation, then you'll be using another shader language, but PlayStation development is definitely not something to be getting hung up on right now. The vast majority of the time, this is fine. OpenGL ES is a fine shader language to use. You can just let the game engine convert it to whatever it needs to. For example, if I were to run the game on Windows, it would be one thing. That's great. And if I were to instead change my export target to Ubuntu and run it on my Raspberry Pi, it would change the shader language to something else, which is also fine. I don't know if this is something we really have to prove right now, but it's kind of fun to see happen anyway. And it's going. And the game works. That's cool. Anyway, the high-level shader language for Windows. So HLSL works specifically with DirectX, with Windows DirectX graphics API. OpenGL does run on Windows. You can use that if you want to, but GameMaker's Windows runner uses DirectX for its graphics API instead of OpenGL, so this is what we've got. There are a few specific things that you can do in HLSL graphics-wise that you can't do in OpenGL because, to make a very long story short, the version of GLSL ES that we are using in GameMaker is very old and doesn't have all of the nice bells and whistles that you might expect in a modern graphics API. And you can do a few of them with HLSL instead. Today we're going to write some of that. To change the shader type, right-click in this little shader editor and go to Shader Type, click on HLSL 11, goes with DirectX 11. And when you do that, you'll see the syntax highlighting has gone away. If you were to try to run the game, then bad things would happen and we would not be able to, because we would suddenly have an error regarding one of the shaders that we're trying to use. The game is actually the game music is actually playing when it did that. Interesting. I guess the game music was set to play before the shader was actually used. Yeah, HLSL is a completely different language. You cannot write GLSL ES code and expect it to compile. Anyway, the way this video is going to work is that I am going to go through a basic pass-through GLSL ES shader and convert it one bit at a time into HLSL. And at the end of this, I will go back to the tune shader I wrote in the last couple of videos and convert that into HLSL. The reason that I'm making this video now is because there is one specific thing I would like to do with tune shaders that's kind of a pain in the neck in GLSL ES with the aforementioned restrictions. So I said earlier that GLSL ES is vaguely C-like in its syntax. HLSL is considerably more so, actually. Either my mouse is suddenly dying or there is like dog hair in front of the laser on the mouse and it's having a hard time seeing the desk. Anyway, at the top of a regular shader in GLSL ES, you will have a list of attributes. These are things like position, color, and texture coordinates, and anything else you might want to include. In HLSL, you will have something similar. You will also need a vertex format, a list of vertex attributes that you supply to the shader, but it's going to look somewhat different. So if you're used to using GameMaker Studio 2.3, you know what a struct is. If you're used to using some other languages like C++, Sharp, you will also know what a struct is. If you're used to the GML version of structs, try to clear them from your mind from the time being. the way you would define a struct in HLSL is somewhat different than in GML. So we're going to say struct, and we need to give this struct a name. So this is like the object name. I'm going to call it VS input, and then some curly braces. Inside these curly braces, I'm going to type a few things. Float3 position, followed by a colon, followed by, in all capital letters, position, semicolon. I'll explain what each of these things are momentarily. Float3, let's call it UV, followed by a colon, followed by text chord 0, followed by, actually that should be float2. I am sorry, followed by float for color, colon, color 0. So you can probably guess what some of these are. Some of the keywords that you will find in HLSL are the same as the keywords that you will find in GLSL ES. Some of them are different. A float 3 is just a vector 3. A float 2 is just a vector 2. A float 4 is just a vector 4. If you were to type something like over here, vector 3 or vector 4 or vector 2, HLSL would not recognize it. The designers of this particular shader language just chose to call them float 3, float 2, float 4, whatever. In addition, matrices, if you were to try to define a matrix in GLSL ES, you would use the type of a mat4, and that would be the data type that you declare your matrix with. In HLSL, it is instead float 4 by 4 is a 4 by 4 matrix. You also have a 3 by 3 matrix, a 2 by 2 matrix, and a 1 by 1 matrix doesn't really mean anything, so that's not a thing. The next thing up, I can, and my mouse is really starting to not respond. This is concerning. There's something on my desk that's causing it to... whatever, let me get rid of that. So the next thing up is the variable name. You can probably infer what these are. These are variable names. We've seen these before in shader languages and in programming in general. These are the names of the variables that you're going to be using. After the semicolon, you have these special keywords. HLSL calls these semantics. These are so that the computer knows exactly what each of these vertex attributes are. So you have a position, you have a texture coordinate, you have a color. And when you draw something with a shader with a particular vertex format, when you say vertex format add position 3D or add color or add text coordinates or whatever, the computer knows how to match that up to the vertex shader. In GLSL ES, that kind of works with the variable name. That's kind of done automatically with the variable name. You have in position, which is for positions, 3D position in the shader. You have in color, which is for vector 4s of colors in the shader. If you want to add extra vertex information, it gets a little bit more weird. Hey! This is something I don't think I actually ever mentioned in the initial shader video, and I probably should have because it's kind of important, and I can definitely make you pull your hair out if you do it wrong, but nonetheless, HLSL has a somewhat nicer way of dealing with it. At least I think so. There's actually a whole list of them that you can use. I don't know if GameMaker supports all of them, but position, texture coordinate, and color are good enough for us for now. Okay. I'm going to delete that vertex attribute list. So the next thing we have here in this default GameMaker pass-through shader is a couple of varyings. When you use GLSL ES, you don't have to use these. You don't have to have any varyings, although most of the time you want to, because that's how you send things like texture coordinates and color information and whatever from the vertex shader to the fragment shader. In HLSL, you do actually need one. In GLSL ES, the position of a fragment is set using a built-in varying GL_position, this thing over here. HLSL has no such thing, and you need to declare another struct. And I'm going to call it VS output, vertex shader output, and it needs to have a few similar things. The first one I'm going to give it is a float for, we can also call this position, you can call this whatever you want. And it's also going to have a colon followed by one of the little semantic thingies, which is going to be SV_position. Okay, Michael from the future here. I'm doing this little postscript at 1:30 in the morning, and I've got to be quiet if I don't want to wake everyone up. So in some ways this isn't terribly important, and in other ways it is. When I was looking up information on the HLSL semantics for this video, I found information that was kind of all over the place, and I didn't really know what to make of it at the time. I found out later that the semantics that start with SV and an underscore are a more recent version of HLSL, whereas the ones that are just like color, position, depth, and whatever are an older version from HLSL 9, DirectX 9. Generally, the older semantics will map directly onto the newer ones, so you don't have to worry about that, but it's probably good practice to use the newer version of the semantics, so SV underscore position or whatever versus just position. I will have a link to all of these semantics in the video description, and you can read through that and see which ones you want to use. I think I got through that without waking anyone up. Back to me in the past. Again, this is the GL underscore position equivalent that you would see in GLSL ES. We also have a texture coordinate, so that's going to be a float 2. I'm just going to call it UV. You could call it text coord if you want. This is just kind of the tradition that I've seen in other people's HLSL code seems to be to use UV instead of text coord. And the semantic for that is going to be text coord. And lastly, the v underscore v color is going to be a float 4 of, we're going to call it color, and the semantic is going to be color. And my mouse is seriously dying. I don't think I like that. I should probably go think about finding another mouse somewhere. As recently as probably about 2 weeks ago, I had a couple mice in my room, and they were all kind of varying degrees of broken. And then I dug this one out of the basement, and it's also not in super good shape. Anyway, you'll notice that SV underscore position and text coord are not syntax highlighted. I don't know why that is. These are valid semantic notifiers. GameMaker, for whatever reason, just does not have them listed as keywords. But they do indeed work, as we'll see soon enough. Also, float 4 for position. This has to be a float 4 instead of a float 3 as a vector 3. Even though you only really have an x, y, and z coordinate in the world in 3D space, the result of this matrix multiplication, the world view projection matrix times the object space position, is a vector 4. GL underscore position, when you use that in GLSL ES, it's only a matter of time before I say that word enough times and it eventually comes out funny. Anyway, this here is also a vector 4. It has a x, y, z, and w coordinate. And the position varying that you create in the Vertex shader output struct over here is also a vector 4. So that's all we need for those for the Vertex shader output. Next, we're going to define the main function. So in GLSL ES, the main function is pretty much always going to be void. It doesn't return any type, and instead everything that needs to happen inside the Vertex shader are set to one of several varyings that the shader uses. In HLSL, that is slightly different. So instead of saying void, instead of saying a main function which takes no parameters and is void, we are going to have a main function which has a return type of vs output, and it takes one parameter of vs input. The input parameter needs a name. The output parameter does not. Part of me wants to say that should be just like a given, but in GML, with its dynamic types, that's not something you usually have to worry about. So when you create a function in a shader language, which is a typed language, you need to specify a type as well as a name. I'm going to call this input. Input is the name of the variable. VS input is the name of the struct that we created at the beginning of the shader, which defines the vertex format. And VS output is the name of the struct that we return, that we will be returning, which contains the information that we're sending to the fragment shader. So let's go through this line by line. First, we have this vec4 object space position, which is created using a vector 4 of the input position .x, y, z, and 1. This is more or less the same, but we will need to change up some of the terminology. Instead of a vector 4, we have a float 4 FAL. I think that's a new way of misspelling that word. Again, for the constructor, instead of a vector 4, we have a float 4. Instead of saying input position.xyz, if you wanted to do this the long way, it would be something like input position.x, input position.y, input position.z. If you wanted to do it in a somewhat more concise way, you could just, GLSL ES would allow you to just say this. We no longer have a variable called input position. Instead, we have an input to the vertex shader. This parameter here to the main function is the blob of data, which contains all the vertex information. You can probably infer that. I don't think I said it out loud yet. Anyway, as with any struct, we can access the position by saying input.position, because position is a variable which is contained inside the VS input struct. Okay. As with GLSL ES, by the way, if you don't want to type out 1.0 constantly for floating point numbers, you can just get away with saying 1 point instead, which is what I generally do because it's somewhat less typing, which I like. That takes care of this line. The next thing that happens is the GL_position is set to the result of this matrix multiplied by this vector 4. Instead of saying GL position, I'm going to say float 4 by 4. I'm going to save this to a I'm going to save this to another variable of type matrix 4 called final position. In HLSL, and I don't know why they didn't do this, but you are not allowed to directly multiply a matrix by a vector 4, or as far as I know, a matrix by anything. Instead, you need to use a function for it and say use the multiply function, which takes two parameters, one of which is this this matrix, this 4 by 4 matrix, and one of which is this vector 4 or float 4.
Hey.
I should get in the habit of saying the HLSL data type names instead of the just like the math data type names. Okay, that takes care of this line. The next two lines, v_v color, these are just kind of directly set to the vertex attributes, and then passed to the fragment shader and interpolated as necessary. So we might as well say the same thing. Float, what is it? 4 by 4? No, float 4. Let's just call it final color is going to equal input.color. Again, color is the name of the variable which belongs to the VS input struct, and the texture coordinate is a float 2. I'm going to call that final UV is going to be equal to the input texture coordinates. So these are all just variables. These don't actually return anything. These don't actually send anything to the fragment shader in any way, shape, or form. I'm going to delete that. What we need to do in order to do that is create an instance of a VS output struct and then return it with the return statement. So the way that you do this, again, this is very C-like, is to define an instance of one of these structs. You just say we can call it VS output, and then the variable name can be output, and this will allocate all of the memory that this struct uses. You don't use the new keyword or anything. You don't need to say anything like equals new VS output the way you would in a high-level programming languages such as like Java, C#, GML. Now does this with its structs. You don't need to do any of this. This will make the HLSL compiler very confused, and it will not work. Instead, you just declare an instance of a struct using VS output, or whatever else you want to name the variable. When you do this, everything inside this struct is initialized to at least what I assume is 0. And then from here, you can set all the variables to whatever you want them to be. Output.position is going to equal final position. Output.uv equals final uv. Output.color equals final color. And then you just return this output struct. This is kind of indirect. If you want to, of course, you can simply assign this directly to any of the variables inside the output struct, but when I'm explaining this one step at a time, I don't really think that's necessary. At the end of the day, a variable is a variable, and you can assign whatever you want to it. It doesn't have to be done one line at a time. So that's the Vertex shader. This is, of course, as you're probably aware, about half the job. You also have the fragment shader to deal with. HLSL has not chosen to call the fragment shader the fragment shader. Instead, they call it the pixel shader. It's the same thing. It's just Microsoft decided when they created DirectX and the high-level shader language that they wanted to call this stage and putting stuff on the screen the pixel shader. It's not like it's incorrect or anything. Each fragment on the screen, each pixel on the screen is what the pixel shader deals with, so it's just a name. It doesn't really change the functionality. So, once again, we'll just step through this one section at a time. In the fragment shader, pixel shader, again, I want to use the HLSL terms for these instead of what I'm used to using for GLSL ES. And most of the time I catch myself like right after I finish saying the wrong word. The varyings. These are what you get from the Vertex shader. Thank God the Vertex shader is called the same thing in both shader languages. Just as in GLSL ES, you would have to declare the same varyings with the same names and the same types. In HLSL, you need to use the the same struct containing the same data instead. So I'm going to copy this and just paste it over here like this. Instead of calling the struct itself vs output, I'm going to call it ps input. The name of the struct doesn't matter. You can call it vs output if you wish, if that would make your job easier. You could name the struct pizza if you want, for all it matters. The important part is that it contains the same information as the output from the Vertex shader. Specifically, the variables in the struct just need to have the same type and the same semantic as the variables in the output from the Vertex shader. The names of the variables don't even have to be the same, since it's the semantic that the computer uses to figure out what's what. In this case, we need a float 4 representing SV position, a float 2 representing the texture coordinate, and a float 4 representing the color. And the actual names can be whatever you want them to be. I'm just going to use the same names as the output from the Vertex shader uses because it's easier to keep track of that way. So the pixel shader, unlike the Vertex shader, does not have any varyings that it assigns to and passes on to the next stage of the graphics pipeline the way the Vertex shader does. In GLSL ES, you have the GL_frag color value, which you assign the final color to, and then you call it a day. HLSL, as you can imagine by now, does not have that. So instead, we are going to do what we've done so far 3 times before, and declare a struct. I'm going to call it ps output out of lack of creativity. You could call this whatever you want, as long as you use a consistent name elsewhere in the program, as long as you name everything consistently. And this is going to contain a float 4. I'm going to call it color, and the semantic is going to be SV_target. And that's going to be it.
Hey.
Next, the main function. Again, as with the Vertex shader, the main function is not going to be a void return type, which takes no parameters. Instead, the main function is going to return a struct of type ps output. You can probably see where this is going by now. ps output main. And it's going to take an input parameter of ps input. And again, I'm just going to call that input because I lack creativity. Same rules apply as the Vertex shader. This is a parameter with a variable name, which is input, and the type, which is the name of the struct which we defined at the top. Inside the main function, the job of the main function is to create an output struct of type ps output, or whatever else you chose to call it. That is not what I meant to copy and paste. ps output. I'm going to just call it output. Once again, you initialize one by just declaring it like this with the variable type and the name. At the bottom, you can return it, and in the middle, output.color is going to be equal to input.color, which is the equivalent to this, to the v_v color varying that you would use in GLSL ES. Multiplied by the result of a texture lookup. In GLSL ES, the texture lookup looks like this. It is a function known as texture2D, which takes 2 parameters, the gm_base texture, or any other texture you decide to provide it, and v_v text chord. In HLSL, it's a little bit longer, and this is honestly probably one of the more annoying parts of HLSL is the actual process of actually sampling from textures. So I'm going to say gm_base texture object dot sample, and the sample function is going to be another. The sample function is essentially the equivalent of this. It is going to take 2 parameters, gm_base texture, and the 2D vector, the float 2 of the texture coordinates, is simply input.uv. And that is how you sample from textures in HLSL. So when you provide texture samplers to an HLSL shader, it's a little bit more complicated than it is when you do it in GLSL ES. In GLSL ES, you would simply define a uniform texture 2D, and I think that's capitalized, the type name, in GLSL ES, and you would give it a name. And that would be the end. You could just use this sum texture variable pretty much the same way that you can use gm_base texture. In HLSL, it's a little bit more involved.
Hey.
When I translate the tune shader so far into HLSL, I'll go into more detail on that. To make a long story short, in HLSL, you not only have the texture 2D. Is that the keyword in GLSL ES? I can't remember. I've been looking at HLSL all day and starting to blend together. But you also have a sampler state, which is another piece of information you need to supply to the shader. which would be the equivalent of this. But this video is starting to get a little bit long, so I think that's a problem for another day. So now when I run the game, I really should change the name of the shader to pass through HLSL instead, because I've kind of rewritten the whole thing in HLSL, but we can cross that bridge later. If I've done everything correctly, which I believe I have, and I have actually not because there is an error popping up. Oh, you know what? This is like the dumbest mistake ever. Let's put semicolons after the ends of these, because the HLSL compiler cares about those. Okay. Oh, okay. The result of this multiplication function is, instead of a 4x4 matrix, it's just a float 4. I was clearly not paying attention when I typed that. And now the game is working. Okay, cool. This does exactly the same thing as before. Let's see, I also saw... Where was I? So technically, you don't need the PS output struct, the output struct for the main function and the pixel shader. You could, if you wanted to, have this return simply a float 4 as a color, and then instead of going through this whole song and dance, you could say just return a color value, return the output color of the input color multiplied by the texture lookup. I believe there is one more thing you would have to do if you wanted to do this. And let's see if my memory is serving me correctly. Yeah, this failed to run. The game didn't actually start this time. If I scroll up and actually find the error message, you see main function return value missing semantics. If you return a float 4 instead of simply a struct, you need to remember to include the semantic on the main function as well. So that would be sv_target, like this. And now the game works as intended, as in, like, it works without crashing. That's just something to be aware of. Most of the time, I would not do that. I would instead have it return the output struct, which lets you do a couple more things. Just returning the color value might be a little bit simpler, but returning the output struct lets you do some interesting things that I would like to make videos on in the future, and is going to be relevant to toon shaders in the future, among other things. I just wanted to mention that you can do that. Okay, that is the basic pass-through shader in HLSL. I apologize for this not really having the game being run in the middle of the video until the very end, but normally when I make one of these videos, I would do that periodically so that you can see what happens when it's in progress. But if you're writing a shader from scratch, if you try to run the game in the middle, you're not really going to see anything besides an error message. And as I've already lamented, shader error messages are kind of pointlessly unintelligible. Although I do think the HLSL error messages are, like, slightly better than the GLSL ES error messages. At least it actually says what happened some of the time instead of just error on line whatever. Half the time in GLSL ES, the error message doesn't even point to the correct line, so that's fun. If you were to try to run this on the Raspberry Pi, nothing would happen. The shader would simply, in this case, not be set because the shader would not be compiled on the Raspberry Pi. You do have a function called shader is compiled. And you can, let's just say, show debug message this in the console down here when I run the game, and we're going to see a 1 or a 0 based on whether or not the shader is compiled. I really should rename this because it's not actually GLSL ES anymore. We're seeing a string of 1s. That means true. The HLSL pass-through shader is compiled. If I were to set the target to Ubuntu, run this on the Raspberry Pi once again, and do this, we would see that the shader will not be compiled. The game window might be obscuring the console, so I might have to move some things around. Nothing's going to happen. There's not going to be any error message or anything like that. Yeah, the game window's obscuring the console, so I'm going to have to... There we go. I don't know if you can see that. We've got a string of 0s. All right. I'm not actually capturing this. I'm just showing it through the Elgato software. We see a bunch of 0s. The shader is not compiled. In this case, I believe in the past, if you were to try to set a shader that did not compile on your target platform, you would see a crash, but that is clearly not the case anymore. This is simply being ignored instead. If you were to have a shader that did something like, if I were to set the target back to Windows and output.color can instead equal a vector, and nope, float 4 of, let's see, solid black, for example. When I run it on Windows, you would see the duckling sprite that the shader is being applied to is just going to be a solid black like this. And meanwhile, if I were to run this on the Raspberry Pi, you would just see the duck as it is. Because the shader will not be compiled on an Ubuntu platform, which is not using DirectX, and the shader set will just be ignored. Okay. And there you have it. The duckling is just as it was. It has not been color modified. So, that is HLSL. I like it as a shader language goes. I like some of the things it does. Some of the other things that it does I think are kind of annoying, like sampling from textures, but that's just how it goes sometimes. I personally like having structs for the input and output formats of both the Vertex and the pixel shader. I think it makes it a little bit more clear about what's going on. But as you can see, this is noticeably more verbose than an equivalent pass-through shader in GLSL would be. Given that this is Windows only, people argue all day and night and like until the end of time about whether or not your game should be cross-compatible with absolutely everything. I am going to say that you should worry about having your game running on a single platform first and then worry about cross-compatibility, because if you don't have a game that's finished, there's no point in it being cross-platform or not. But that's for you to decide. Like I said, there are some things that you can do in HLSL, one in particular that I will be talking about probably soon, which only works in HLSL, that does not work in GLSL ES. But that can wait for another day. Until then, my name is Michael. I like wizards and dragons and making games. I'm probably going to have another video up, probably alongside this one, on converting the toon shader to HLSL. I was going to do that in this one, and then it went on for like an hour and a half, or at least the recording did. I don't know what the final video is going to be, and I said I'd rather separate that out. If you want the code for this, I will have a GitHub repository in the video description. You know what? Let me pass through HLSL. We gotta have accurate names here. I'll leave this printout running, just so that you can see if it works on your device or not. If you're using GameMaker on a Mac, I'm sorry, you're kind of out of luck here, unless you have a Windows device set up that you can remote into and run the game. But yeah, code, video description. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that around as well. Otherwise, I hope you found that useful, and I will see you all later. Special thanks to David Key, Edward Holt, Emily Koyo, Jason, and Zenith for supporting these videos. If you want to get access to these things a day early, or to see your name in the credits, head on over to the Patreon page in the video description to join the fun.